Good morning, guys. Again, I'm sorry I can't be in the classroom today. Uh, I am called away right now, and so this is not ideal. I do want to be in the classroom with you all. One, to answer your question, but also so that I can. I think it's more effective when I'm in the classroom. That being said, guys, I mean, right now I don't have a choice. I can't be in the classroom, and so for right now, this is how I can reach you all. And so we can't get that far behind, so I do need you to push yourselves so that we can get through this chapter. So this is something that I was hoping to show you all later on in the week. However, due to circumstances, I am going to go ahead and show it to you right now. That way we can continue where we left off, hopefully by Wednesday, if not Thursday. So this chapter is called Composition of Functions, and again, you're going to need your formula sheet. So a couple things. You should find in your formula sheet a section called Compositions. Okay. And so this really just builds on a lot of the stuff we've been talking about, inputs and outputs. So the thing about this right here is I'm gonna have two equations. Now, I mean, they don't need to be called F and G, but usually they are. So that's what they're talking about here. So if I have two equations, we call it F and G, okay? Essentially what we're doing here is we are composing them, is what it's called. And so the composition of F and G, so what we're doing is we are combining them. So is noted F of G, okay? And so really the big definition here, so everything I'm underlining, go ahead and write it. F of G of X is equal to F of G of X, okay? Sorry about that. So here, guys, a little note here. I am combining two functions. Okay, now the way I'm going to read this is the composition of F and G is denoted this way. F of G of X. What this means here is you plug the G equation into the F equation. So whatever's on the inside, you plug into the other. And so pretty much this is just showing this is my input, and my output would be whatever this F equation is after I plug it in. Okay, so opposite here, G of F of F is noted as G of F of X, which means this right here is my input, so I'm going to plug in the F equation into the G equation. Okay, so make sure this makes it into your notes. Again, I'm plugging the F equation into the G when the G is on the outside, plugging the G equation into the F when the F is on the outside. So, moving forward here into the actual lesson. Again, if you need time, go ahead and ask the sub there to pause the video. I'm denoting here that I'm going to start with this one here because this one's a little bit simpler to understand here. So I can write it two ways. The way I saw it there, the way I just finished writing in the notes, or this right here. So this says F of G of X. So what I'm saying here is the F is on the outside, the G is on the inside. So here, this is my input, and the F is the output. Okay, so here what I'm doing in the first one is plug G into F. That's what I'm doing. Okay, so plug the g equation into the f equation. So plug this equation into this one. So everywhere I see an x, I'm going to write this right here. So let's go ahead and start writing the f equation. So the f equation says 3x plus 2. So I'm writing the f equation here, 3. But instead of an x, I'm going to write x squared plus 2. And now I continue the equation, plus 2. So essentially what I wrote here, this is the f equation, the outside, and I inputted the whole g equation for x. So when I distribute this, this becomes 3x squared plus 6 plus 2. Okay, which after I combine like terms is 3x squared plus 8. So my composition function is this right here. Okay. So give me just 1 second here. So if I continue, oops, it's a little blurry. With this problem right here, again, I can write it 2 different ways. Here, the g equation's on the outside. The f equation is on the inside. And I know that the g is on the outside because it's the first one I see. So here, this is the input now. So I plug the f equation into the g. So again, this is my g equation. Every time I see x, I'm going to plug in this equation here. So seeing this is x. So instead of x, I want to write 3x plus 2 squared. Okay, and then I continue the equation, plus 2. So what I'm going to do here, again, now I see this exponent. I'm going to write it 2 times. Write it again. And I'm going to expand it. So do the rainbow method here, or FOIL, whichever you're more comfortable saying. This becomes 9x squared, and then 3x times 2, 6x, 6x plus 4, and then don't forget the plus 2 that was already out there at the end. And when I combine like terms, these two add together, and these two add together. So g of f of x equals this right here. Okay. So there's a little bit of I think there's like an extra step to do when I'm dealing with these, when I have a number in there. But I do think these are easier to solve, okay, because they're a little bit more straightforward. So what I see here, though, it says f of g of 2. So here, we're going to have 2 inputs. So we're going to start with this part right here, just the g of 2. So I'm going to write g of 2. Okay, so my first input is the 2 into the g. So I'm going to put a 2 in here for the g every time I see an x. So this becomes 2 squared plus 2, okay, which equals 4 plus 2. So g of 2 equals 6. Okay, and now from this point, what I'm going to do, remember, I don't want g of 2, I want f of g of 2. Well, if I already know g of 2 equals 6, what I'm going to find here is f of 6. And now all I have to do is plug in the 6 into my f equation. So 3 times 6 plus 2. which equals 18 plus 2, which is 20. So f of g of 2 equals 20. Now, same thing here. Let's start first with the f of 2. So I'm going to write this off to the side. F of 2 is equal to, so again, starting with the f equation, but instead of an x, I want to plug in a 2. So 3 multiplied by 2 instead of an x plus 2, which is 6 plus 2, it equals 8. But I don't want f of 2, I want g of f of 2. So this now becomes my new input into this equation, because I know what f of 2 is. So g of 8. So over here, I'm going to plug it in 8 for x. So it's 8 squared plus 2, which is 64 plus 2. It equals 66. So g of f of 2 equals 66. Okay, so at this point, I'm going to ask you guys to go ahead and, or I'm going to ask the sub, can you please pause the video? You guys will now have, let's say, 5 minutes, work on the next set of problems yourself. Okay, so if you guys have already worked it out, this is what you should have ended up for those answers. So if you did not, go ahead and see what your mistake is. But this is the correct set of answers. Okay. And the final problem that I want to show you all here is we can apply this to a word problem as well. And so this is something we saw last year. Okay, and so it's applying the same concepts here. So here they told us the amount of waste burning in an incinerator is 5t squared minus 30t plus 125. Where T is the temperature in waste. When the waste is removed from the incinerator, the waste cools down using the following function, where the little t is the time in hours. So find WTT. Okay, and so what I would do here, guys, is they're telling me this is my input, and I want to plug it into the big equation. So this is my T of T, this one right here. This equation will go into this one every time I see a big T. So what I'm doing here is I'm going to rewrite this equation. So 5, and now I see a T, so instead of T, I'm going to write this equation. 5 little t plus 4, and this is squared. Minus 30 times 5 little t plus 4, because I see a big T again, plus 125, okay? Now, again, guys, you're going to need to simplify. This is the correct answer, but you would simplify. So this is going to be 5 times, and then 5t plus 4, 5t plus 4, because it's squared. I'll distribute this, so minus 30 times 5 is, excuse me, 150t. Minus 30 times 4 is minus 120, and then plus 125, okay? Continue to work with this. So this becomes 5 multiplied by 25 t squared plus 20t plus 20t plus 16. Okay. Again, this is only this part right here, minus 150t, and we can go ahead and add these numbers, which negative 120 plus 125 is plus 5. Okay. Now I don't want you to get scared about this, guys. If you have a problem like this, you would have a calculator. So right here, continuing, this would be 125 t squared plus 100t plus 100t, and then 5 times 16. I'm actually not too sure what that number is, so I'm going to go ahead and put that in the calculator. Okay, that's 80 minus 150t out here plus 5. So final answer here is 125 t squared. 200 minus 50, so plus 50t. Again, I'm just combining like terms. All of these have t's. And then 80 plus 5 is plus 85. Okay, so that's my equation there. And they go on to ask me approximately how many hours of after the waste is removed from the incinerator will the waste reach 1250. Now remember, they're telling me waste, which is W, right? So, and since we already have our equation set up in time, what they're really telling me here is when will it equal 1250, this whole equation. And if I use NSolve here, I will find my answer. So again, guys, I'm sorry I can't be there. I hope that you can follow this, because it will be tested, and I do want you to push yourself, because I don't have a whole lot of time to go over this stuff with you when I do return. So please push yourself, and I will see you in class.